Hello ladies and gentlemen, and welcome back to another Kubernetes video. Today I'll be talking about the core component of the monitoring stack that we are discussing in the current series, and that is Prometheus. In this video I'm going to go into how to deploy Prometheus along with the other components that go hand in hand with Prometheus. I'll then go into some of the configuration that we can do in Prometheus, including how to create a new alert, and after that I'll look at some of the implementation details like the storage and the service discovery capabilities that come with Prometheus. So let's get into it. First of all, let's have a quick overview of Prometheus and how it integrates with the other components of the monitoring stack. It collects metrics from endpoints, and in the last video, if you haven't seen that, I discussed metrics and how exporters are configured, which Prometheus then scrapes those metrics from. It stores time series data using a time series database. So this is a highly customized data format that Prometheus uses to write the time series data in a very efficient manner to generally local disk, but there are other options as well, and we'll talk about that a little bit later. It pushes alerts to Alert Manager, and it provides service discovery. And this diagram illustrates all of this. Prometheus is the core component, as I mentioned. It can retrieve metrics from an exporter that will be bound to a service. It can also retrieve metrics from this push gateway component, and again we talked about that a little bit more in our last video. Once that is done, it stores the data in its storage, this time series database. It also has the service discovery capability, which will then allow you to automatically discover new exporters if you're using, say, a cloud provider or something like that. We then push alerts to Alert Manager, and we allow Grafana to pull data in order to provide visualization. So that is the high-level overview of how Prometheus works. And now let's get into some more details. And first we will talk about how to deploy Prometheus. So Prometheus can be deployed using a Helm chart, and this is the easiest way to get up and running very quickly. It's what I've used in the past, and you can go from a bare bones cluster to a full monitoring stack deployed within 2 minutes. So all you have to do is run these two commands, assuming you have a cluster and Helm installed. If you don't, then again, it is very easy to get those set up. Just Google how to set up a Minikube cluster and how to install Helm, and you'll be ready to go. So let's say we have Prometheus set up. So if we look, we have Alert Manager. This is the Prometheus stack has been deployed. We have Alert Manager, we have Grafana, we have the Prometheus stack operator, we have Kube State Metrics, which is a exporter, we have the node exporter, which is another exporter, and then we have Prometheus itself. So if we have all of this defined, how do we go and configure a new alert in Prometheus? Well, the first thing that you have to understand is that when we deploy Prometheus using this Prometheus Helm chart, we have a number of custom resources that will get deployed alongside the other components in Prometheus. So if we do kget CRD, and by the way, I've just aliased K to kubectl, so if you want to do the same, run the same command, you just do this right here, but I've already done that, so I don't have to. So these are the custom resources that are defined. If you don't know what a custom resource is, in Kubernetes we have standard resources like pods, services, deployments, and so on, but we can also have custom resources that are defined by some third-party entity. Then you just deploy the custom resource and they will become part of your cluster. So for example, we have alert manager config, alert managers, pod monitors, probes, Prometheus rules. And that is what we're interested in if we want to define a new rule in Prometheus. So let's say, okay, get Prometheus rules. You can see that we already have a lot of rules defined within our cluster. This means that when we deployed the Prometheus Helm chart, we also deployed a set of default monitoring. So all of the components that we have within our cluster will have alerting rules already configured for them. So for etcd, we have a set of rules that are standard rules that we can leverage to set up the monitoring that we want to set up. At this point, we're only monitoring, we'll be able to see these alerts in Grafana in Prometheus, but we won't be able to receive notifications from these alerts. In order to do that, you would have to set up new receivers using Alert Manager, but I will talk about that in the next video. But let's quickly look at one of these sets of rules. Let's do that. And this is the format that you'll get. For each alert, we have the alert name, some annotations like the description, a summary of the alert, the expression, and this is really the key field, or one of the key fields, that defines what is the threshold that will be used to determine whether the alert is firing. And then we have this for field. The for field will, let me just zoom in a little bit, apologies, will determine how long we have to wait before the alert goes from a pending state to a firing state. So you can imagine in a lot of scenarios, we wouldn't want to just, if say some component gets restarted due to an issue and Kubernetes decides to restart it, we wouldn't want to get notified. In that case, we would want to ensure that there's actually a persistent issue before manual intervention is required. Then we have labels, and a lot of times we'll define severities like critical, warning, or info. So what would we do if we wanted to add a new alert? Well, we'd simply edit a Prometheus rule. So come down to the bottom here, and we'll just yank 13 lines and paste, and we'll just rename the alert here. My new custom alert. And if we want to ensure that this alert is firing at all times, what we do is we just set it to vector 1. This means that it will show up in the firing alerts in Prometheus and in Alert Manager. And we can set the for to 0 minutes and it will go straight to firing. Okay, I need to yank this line as well. Put that in there, and then we should be good to go. This is our new alert. Now we can go to Prometheus. Let me just pull up a new tab, new window. And this is Prometheus, and this is how the UI looks. And let's go into our alerts. First of all, what we have to do is run a post request in order to reload the configuration. That's how our new alert will be picked up. Now if we come in here, hopefully No, we don't see it yet. Is it in there? My new custom alert is there. You just reload. Yeah, so now it is firing. It just took a second for that to work its way through. So there you go. Very simple to add new custom alerts if that's what you want to do. Now let's take a little look through the actual Prometheus dashboard itself. What are the different UIs that you can interact with, and what are the important components that you should be aware of? The first thing that you should obviously be aware of is how to search for different time series and how to write expressions. I'm not going to go into detail on all of the functions that you can use to write expressions in this video, but the absolute basics are that you should be able to search for a metric such as kubelet HTTP request total. Then you can execute that and see what time series has come up. Let's say you want to get an average, you can do that too. So you can see over time that it's increasing. You can also look at the table format. So the graph format will give you whatever time series that you have all across, and the table format will just give you a list of the time series and their data. So that is the basics of querying in Prometheus. There's a whole lot of detail that you can go into in terms of learning PromQL, which is the query language that we use here. But just understand that every single set of a metric name and labels will correspond to a single time series in Prometheus, and that's how it will be graphed. So over time, new values will be assigned to the time series, and that's how we'll see variations in the graph that we see here. Other important UI dashboards within Prometheus are TSDB status, and as I said, TSDB stands for time series database. We can check out the total number of series, the most common labels, the top 10 series count per metric name. So if perhaps there were custom metrics that we were generating and we saw that we were generating just way too many metrics for a particular application, then we could go in, modify our logic and do some sampling or something to that effect, because there is an infinite amount of data that Prometheus will be able to hold depending on the size of the hardware that is running on. Label names at high memory usage. So all of this depends on your use case, but you can glean some useful information here. You can look at the actual Prometheus configuration. So this is a big file that will have a whole lot of data, but this is sort of abstracted away from us when we work with the Prometheus operator, but there are certain important configurations that we still will have control over, and I will show you some of those in a little moment. Then when we define new rules, we can verify that they've actually been created in the rules endpoint. So my new custom alert is here. We can see that. And importantly, we have this targets endpoint that we can look and verify if we're adding new targets, i.e. there are new exporters that we want to scrape from. We can verify right here, and we can see if the target is up, and if a particular target is down, you can see more information about it, like say the IP address and the port. And if you find out something like the IP address and the port is misconfigured here, you'll be able to go and just make a modification to your configuration rather than trying to debug for a long period of time as to why Prometheus isn't picking it up. So these are all very useful dashboards that you can look at within Prometheus. Now, let's say we want to go and add another scrape endpoint to Prometheus. How do we do that using the Prometheus operator? As I mentioned, the Prometheus configuration is managed by the Prometheus operator, we don't have direct access to make changes to that. So if I go here, we can see that the Prometheus config is defined within a secret, and if we have a look at this secret, we'll see that is actually a zipped YAML file that has been base64 encoded. So this is not something that we would want to modify directly. Instead, we have the option of adding additional scrape configs. That is just an additional secret that we will define, and then we update the Prometheus operator itself, so, or the Prometheus custom resource itself. So as I showed you kget cruds, we see that we have a Prometheus's crud. So if I go kget, we see prom q Prometheus stack Prometheus, and this will manage the configuration. It'll verify that what we have defined has been reconciled, and this is the central point to any configuration changes that we want to make. But let's say we want to add a new endpoint, and it looks like this right here. It has the IP address of 192.168.1.1, and it has this port 9100. So this is a standard case where there might be a new server that was introduced to our environment, and we're running the node exporter on that server, and we want to expose it to Prometheus. Well, the way that we would do that is we would just define this Prometheus additional YAML file, define the job, and then we run this create secret command. I'll just run it right here to show you what will be created. So we have essentially defined the contents of that file in a base64 encoded secret, and the key is right here. Now, once this has been added, we can just go to that, and now the secret has been added. Kget secret to verify. Additional scrape configs is right there. Now all we have to do, and our new endpoint will be onboarded, is to update the actual Prometheus custom resource itself. So what we have to do for that is simply edit that custom resource. Let me just get it again. Kget Prometheus's. Boom, boom, boom. And this is what we want. We'll actually just edit it directly. Prometheus's. And what we do is we just put these additional lines into the file, which are additional scrape config, and the key is Prometheus additional.yaml. The name is additional scrape configs, and that will set everything up for us. And if we reload and return back to Prometheus, we should see in our targets we have a new endpoint, which should actually be down, because it was just a nonsense endpoint that I defined. This may take a moment to propagate, and there we have it. The new endpoint, the new scrape endpoint, has been picked up by Prometheus. As I said, this is a nonsense endpoint. It doesn't exist, so it is in the unhealthy state, but this was just for the purpose of demonstration. Now you know how to add an additional endpoint to your Prometheus setup if you want to. So now that we have looked at how to define a new alert and how to define a new endpoint in Prometheus to scrape metrics from, let's have a look at service discovery, because in a lot of enterprise environments, we'll simply have too many endpoints to manually configure. We want to have more of a catch-all situation where we can define rules that will automatically discover new endpoints when they are created, and that's what service discovery allows us to do. So in this example, I'm going to talk about how we would do it if we had a set of EC2 instances in AWS that we wanted to discover using Prometheus. The first thing that we'd have to do is to install the Prometheus discovery tool. We would then have to configure that tool, and there are specifics for each tool, so I'm not going to go into those specifics. Then we configure the Prometheus scrape configs, similar to how we had in the example that I showed. However, there are some additional fields that you should be aware of here. We have EC2 SD configs. We have the region that we are going to be scraping from. We have the access key, the secret key. This will allow us to actually access the AWS API. Then there are filters that will allow us to select the specific EC2 instances that we want to scrape data from. So the filter that we have defined here looks for a tag that's called name, and then the name of the instance is the value of that tag. So there might be some regex that we place here. It might be a list of names. The important thing to know is just that we are accessing the AWS API, and we are specifying a certain list of filters that will allow us to select the EC2 instances that we want to select. And that is essentially it. We then define the port that we want to scrape the metrics from. That means that all of the EC2 instances will be exposing metrics on this particular port. And from that point on, we no longer have to define new scrape configs when we are creating new EC2 instances. As long as they match the filter that we've defined here, then they'll automatically get added to our Prometheus endpoints. That obviously saves us a lot of manual effort. Now, let's have a quick look at Prometheus storage before we wrap up. Prometheus by default uses local storage, so it has a custom storage format that is optimized for time series data, and you will be able to see that directly on disk. In fact, if we do a kubectl and we have a look here, within the Prometheus directory, we have all of these different blocks. So these are different blocks that Prometheus uses to store data. The blocks are stored every 2 hours. Within the blocks, we'll have this meta file where we can take a look at, for example, the range of time at which the block is storing data for, the number of samples, the number of series, the number of chunks, and so on. And then the actual data itself will be stored within here in chunks. And we can look at that. It's all binary data that isn't going to make a lot of sense to us. So older data is then compacted for storage efficiency reasons, and we also have the option to use third-party storage. So we can write out to maybe some cloud-based storage solution, but by default it is based on local storage. So that is my video on Prometheus. I really hope that was useful. If you have any questions, please do leave a comment and I'll get straight back to you. Please like and subscribe, and I will talk to you in the next video.